9EB, polymers. In 9EA, we came across this lattice structure of atoms, and now we imagine what it would be like if instead we had a long, windy chain of atoms. So these long chains can occur naturally. Rubber is a key example of this occurring naturally, but we can also make these in labs and factories using little pieces, chunks, and putting them together to make the long chain ourselves in a process called polymerization. The little chunks are called monomers, mono usually meaning one, and the polymerization reaction brings these little monomers together to form this long chain of molecules. And poly meaning many, monomers become polymers. There's a nice picture in your book of lots of different examples of the kinds of substances that we could zoom into and find these polymers inside, making up the structure of these items. Ooh. Now, polymers in general might remind us a bit of ceramics because the properties they have in common are that they are strong, hard-wearing, insulators of heat and electricity. Again, one difference is that they're flexible and often waterproof. Let's talk a little bit more about rubber. So this is this natural form of a polymer. This comes from trees. Again, a lovely picture here. There it is coming out of the tree. Now, if we just use this as it is to make a substance, it can be quite brittle. It can have some problems. So we actually tend to treat the natural rubber to make it more useful for us to use through a process called vulcanization. Here, we borrow a bit of sulfur and we make a chemical reaction which really improves the hardness and the toughness of the rubber. How this happens is that through this reaction, there are cross-links made between the polymers. So where they had just been lying next to each other very nicely, we now have cross-links joining polymers together inside the material, making the material overall much stronger. And whereas before, the natural rubber, if you stretched it, it would remain stretched. Stretched it, stay stretched. We actually call this plastic. So that's acting in a more plastic way. After this chemical reaction, after the vulcanization, the material can be stretched and it'll spring back. Stretched, spring back. And we call that elastic. So now it's gone from plastic to elastic, and that's much more useful. To come back to the synthetic versions, the man-made versions of these polymers, you just need to know that they get the raw materials for the polymers from crude oil, generally. That's where they get their monomers from, the little pieces that make up the polymer. They get the monomers from crude oil. They go through the polymerization reaction, remember? And you need to just remember that this is an exothermic reaction. Exothermic means transferring energy out. So when the reaction happens, energy is transferred out to the surroundings, not in for an endothermic reaction, an exothermic reaction. And some common synthetic polymers that we make ourselves are PVA, like PVA glue, which is short for polyvinyl acetate, polypropene. Make a note of the fact that these all start with poly because it's talking about these little pieces making this longer chain of many pieces together. We've got this.